VLPSos here. This is a video lesson for Python programming color. I'm starting with stub 0. I'm going to keep the width and height of the screen. I'm going to change the caption to the topic of this lesson, color. And I'm going to add a comment under the booleans, but before the frame loop, where I'm going to create the color variables that I'll be using in this program. A section for colors. Now, previously we had shown our first color to be a tuple of 3 values, and those values for what we call the color white were all 255. 3 values of 255. What a color is it's a combination of 3 additive primary colors. 255 is the maximum amount of those 3 primary colors. The primary colors in this color mode that's typical for using Pygame unmodified is red, green, and blue, are additive primaries. So in the comment, I will put a description of what those values mean in a tuple of 3 for a color. They are red, green, and blue in that order. 0 is for no amount of those of either one of those primaries, and 255 is the maximum amount. So if you create a color tuple that has any values that are lower than 0 or greater than 255, you will break your program because it won't be recognized as a legitimate color tuple. White, when we use additive primaries, that means that it's the actual wavelengths of the light that is going into your eye is composed of an even amount of very bright red, green, and blue. All together make white. Black would then be the absence of any of these primaries. So we can make the black color, so to speak, by having a tuple of 3 zeros. No red, no green, and no blue. We can create color tuples for those additive primaries. The additive primaries are red, green, and blue. So if we wanted a pure form of these colors, then red would be 255, a maximum first value, and for red, and no green and no blue. That would be pure red. Green would then be no amount of red, so a first value of 0, a maximum amount for the second value, and no amount for the third value, no blue. Blue, of course, then is 0, 0, 255. Maximum blue, nothing else. Now that we have some colors, let's see them. So we see the color if we put graphics or fill up our graphics display, in this case screen, with something that's colored. The simplest way to use a color is to simply fill the screen with that color. The screen starts filled with black. And we fill the screen. We're going to make a comment. Fill the screen with a call to the fill function on screen. So it's screen.fill, and the argument of fill is the color that you're going to fill it with. Let's fill the screen with red. We will then, the user will then see the update of that fill here. And our while loop will continue to process because we have nothing that quits out of it. Let's see what happens. We have our screen size of 800 by 500 completely filled with absolutely pure red. And we'll quit out by exiting idle. If we wanted to make this a little more exciting, we could cycle through the colors that we can see based on the frame count. We have a value that we call frame. I forgot to mention that I've also added two constants. I've set color underscore index to be 0 and change count to be 2000, and we will use those values in a moment. But first we're going to use the frame value, and here's how we're going to do it. We are going to add 1 to frame each time. So every time our while loop, which we call our frame loop, runs, then the frame number will go up by 1. If frame is greater than or equal to this other variable called change count, and change count was a variable that was set with an initial value of 2000, then if our frame number, which is constantly going up from 0, gets to be greater than or equal to the value of change count, then we'll do a few things. First of all, we are going to subtract change count from the current value of frame. And I'll explain why we're doing it that way in a moment. But let's get some other changes. We're going to refer to this variable color index. We will increment color index. We will add 1 to it. So what's happening so far when we run our program, we have frame and change count and color index. Frame is going up, and when frame gets high enough to be greater than or equal to change count, in this case 2000, then frame will be reset by subtracting that amount from change count, and color index will go up. In other words, as this program processes, then every time frame gets to be up to 2000, it's set back down to 0, and we add 1 to this variable called color index, which we're going to use to change colors in a list. So we're going to create a list of the colors that we defined. We're going to name that list colors and put into it red, green, and blue. Not black and white, because those are so basic. We want to see red, green, and blue. Now that we have a colors list, color index might make a little bit more sense. So back in this section of code, which I'm going to comment to be what we're doing with it, count frames to change colors. And the color will be from the list with the color index. If the color, but we have to be careful, because if the color index ever gets to be greater than the length of the list, it'll cause an error. So we're going to say if color index is equal to the length of the list of colors that we defined, then we have to set it back to 0, so it doesn't get longer than the list itself. So what we're going to fill now comes from the list of colors, specifically the color with the index equal to the variable color index. Let's see the effect, and maybe that'll help explain what we just coded. We see red, and I misspelled change count here. We see red, then green, then blue. Back to red, green, then blue. And it's at a regular pace. So now that we see the effect, if you haven't got an understanding of this code, let me explain it one more time. The value of frames was set equal to 0 and is going up by 1 every time the while loop iterates. So if the frames are going up, eventually we can compare frames and change count. So if frames is greater than or equal to change count, then we take change count away from frames. Imagine this value going up, and once it reaches a certain height, it goes back down immediately so that it can go back up again. And it keeps going up and being reset. But every time it gets up and reset, something else happens. This variable called color index is increased by 1. And we call that color index because we're literally using that value as the index in a list of colors. And we define that list of colors and put 3 colors into it. So if we have color index equal to 0, then, and we index colors with that 0, we'll get the color red. But if we're increasing color by 1, then the index will go up and access green in the colors list, then blue. But we have to be careful with color index because it can't get too big. If we try to index a position in a list that doesn't exist, then it will break our program. So we added this bit of code to say that if color index after it went up is ever the length of colors, which is too long, then we reset it to 0. That's why we see the colors go red, green, blue, back to red. Now that we have a way of seeing all of the colors, we can define and view more of them. If on your computer you run code like this, what is changing the pace, what is controlling the speed of the change, is the value of change count. In my computer, I set change count to be 2000. If you want it to go faster, you give it a lower value. If you are working on a slow computer, you might want a lower change count so that it doesn't take too long. Let's make some more colors. I talked about red, green, and blue being additive primaries. That means that these are the primary colors to create all colors that humans, typical humans, are capable of seeing by that light adding together as light that goes directly into your eye. There is another set of colors called subtractive primaries. That's when white light hits something like a piece of paper, and the paper, the pigment on the paper, absorbs the wavelengths of light and reflects only those that it doesn't absorb. So if we have blue written on paper, what the pigment of blue on paper is actually doing is absorbing all of the colors of white light except for blue. So what you see is just the blue that's reflected. Now computer monitors are additive color physics. The colors that we see from a monitor are actually the light that's generated by the technology of the screen as light that goes into our eye, additive primaries. But we can still make our subtractive primary colors, which are magenta, cyan, and yellow. Those are the specific names for those colors because those are very specific colors. The subtractive primary magenta, which I'm trying to spell with capitals, has a color value of full red, full blue, and no green. Now when we mix blue and red, you might think purple. Sure, magenta is purple. But magenta is a very specific purple. It's a purple that is made out of even red and blue quantities and absolutely no green. It's a very specific color, and we could say that magenta is minus green. It's white light with the green taken out of it. Another subtractive primary is called cyan. Cyan is no red, full blue, and full green. This is a very specific color. Most people think of it as blue, but cyan is not blue. It's only exactly half blue, and the other half is green, additive light. We could call this minus red. So what do you get when you subtract blue? The color tuple would be full red, full green, and no blue. And we could call this color minus blue. What is that color? Let's call it mystery for now. It's surprising to a lot of people. And we're going to include magenta, cyan, and our mystery color, and take a look. Red, green, blue, yellow, cyan, and yellow again. I made a mistake, but not because it was yellow, but because, of course, minus green was supposed to be a 0 green value and a full blue value. Those watching might have seen me do that. This is now minus green, yes, minus red, yes, and our mystery color, which was seen twice, red, green, blue, magenta, cyan, and yellow. Very interesting. Yellow is minus blue. We have our 3 additive primaries and our 3 subtractive primaries. And we can see how the screen was filled with those colors. I'm going to replace mystery with yellow and do one more thing. We, of course, can use colors when we create shapes. With the comment, drawn objects can make use of color. From the previous lesson, we've learned how to draw a rectangle. Let's draw one now. The argument of a rectangle first needs the surface it's going to be drawn to, in this case the screen, then a color, choose red, then a tuple of 4. The first 2 values are the coordinates of the top left corner, and then the third is the width of the rectangle, and the 4th in this tuple is the height of the rectangle. I'm going to base the width of the rectangle on the width of the screen. So whatever the screen size is, the width of the rectangle is going to be 40 pixels less than it. I'm going to break my line and base the height of the rectangle on the height of the screen. The height of the rectangle will be 40 pixels less than height. That means that I can change the width and height of the screen, and this rectangle will adjust dynamically. I've finished that tuple of 4. I need the line thickness last. Let's see what happens. I'm drawing a red rectangle based on the screen's dimensions every time. But of course you can't see it when the red rectangle is drawn on top of a red screen fill. Now you have seen how to assign tuples of red, green, blue to variables chosen to represent colors. Explore modifying the color values to find some colors you like. Find and name at least 3 new colors and include them in this program. You can use this code file as a stub. Your colors must include at least one of the following. So I want at least 3 colors, please. And you can, after experimenting by changing the color values, include colors that you like and prefer, but I need you to make an effort to find at least one of these colors. Orange, purple, though magenta is purple, how about a more traditional, deeper purple? And for a challenge, brown.